Hi, this is Kristen Hess. I want to talk to you about one of the problems from tonight, and I will use three-column notes to help model this. Specifically, we're going to talk about problems that involve cost, revenue, and break even. So as we're doing this, I want you to think about what is revenue, what is cost, what's break even, and what's the relationship between all of these. Some of these might be really intuitive, and some of these might just be new words that you've used other ways, or you understand the concept that you've heard it used differently. So revenue is generally income from a business. Cost is going to be the money spent by the business to produce something, and then the break even is a point where the revenue and the cost are the exact same. So the money that they put into that they use to make something is the exact same amount that they earn from it, and so they come out exactly even. They don't have any extra money to expand or buy new machines or give raises. So here's an example. And notice that I have the three columns set up here. On the next slide, I'm going to zoom in on the example so you can see it better. So we have a manufacturer of household items that has a total revenue given by the function R for revenue is equal to 19.5x, and x would be the number of things that they're making. And it has a total cost given by C for cost of 17x plus 250. So for every X items they make, the cost to make them is this C equation, and the revenue equation is this R equation. And X is the number of items produced and sold. So this could be books if it was a bookstore. It could be boxes for a box company. It could be bushels of potatoes for a potato farmer. So the key information we need to be aware of is the revenue equation, the cost equation, and knowing that we're looking for the break even. So I am going to pull out my graphing calculator on Desmos.com. And I want the break even point. So with both of these, I'm going to change the R and the C to a Y because Desmos, you need an X or Y. So I'm going to have the revenue equation be Y equals to 19X. And notice I have this red line here. And the cost equation, I'm going to replace the cost with Y is equal to 17x plus 250. Now you notice I can't see the second equation, and that's because this y-intercept is at 250. So I need to change my intercept. And the numbers are going to be a lot bigger. So just to give you a feel, I'm going to zoom out a few times. So notice how they don't even look like they intersect quite yet. And as we get up to these bigger numbers, they do start to intersect, but it's hard to see. So looking side to side, I know that if I keep my numbers between negative 100 and maybe negative and positive 200, I will be able to see it from the horizontal perspective. So I'm going to change the x-axis from to a negative 100 to a positive 200. And the y-axis, I need it to go up just a little higher. So it's at 2,000. And I'm going to put it at 3,000. And now I can see that they intersect here. And I can move this around a little bit. But what we want to do is find the one point where the two lines cross. And it's going to be right here. I do know that I didn't type the equation in correctly, so I'm going to change that 19 to a 19.5, and it's going to change it just a little bit, but it gives us this point right here. And what it tells us is that when x is 100, when you have 100 units, so that means you sell 100 units and you produce 100 units, your y value will be 1,950. So when your revenue is 1,950, your cost is going to be 1,950, and they're going to be the exact same. So back to our question. Use the graphical methods to find the number of units at which the company will break even for the product. And so in our case, it'll take 100 units to have the break-even point where the revenue and the cost are the exact same. Feel free to email me or reach out to me with any questions or any other ways that I can support you on this. Thank you.